Welcome back. So here is the next problem. So read the problem. You have two planes which are inclined, making angle 45 and 30 with horizontal respectively. On these inclined planes are placed two weights. They are attached by string which is run over a pulley. This is weight 2 or body 2 and body 1. You are given the weight of, we want to find out the weight of body 1, its maximum and minimum value. What you are given is weight of body 2, that is W2, right? You are given W2 and you want to find out the maximum value of this and minimum value of this for this to be stationary, right? This is something which I should have written. So what is the maximum value and what is the minimum value? And in both the cases there should be this should be under static equilibrium. Okay, so just think about it. So what you have is let's say weight is of course W2 is, I'll show it here, W2 acting, I should use colored pen, maybe that's better. So I'll show it here. W2, and which is 2.5 kilonewtons. This is acting downwards. You want to find out maximum and minimum value. Now understand what do you mean by maximum and minimum value. See, when you are going to decide this weight, that you can decide it in two ways. In first case, you can say that the weight here would be enough to stop the sliding of this body downwards, right? So it just, the body tries to slide down, but the weight is such that it won't slide down. So it just enough to arrest the motion of this body downwards, correct? If there is no weight, this would going to slide downwards, right, along this. So you keep on increasing the weight, and at a point this body will not slide down. Okay, so that will be one value of body A. The other value of body A will be, you are not interested only to stop this, but you are going to push it upward. That means it's about to move upwards, right? Consider these two cases. When it is stopped from going down, right? That's one value of weight. And in second case, it is pulled. It is about to start moving towards right. Okay. So in the second case, you will get maximum value. In the first case, when you are just arresting the motion of this body which is trying to move down, that will be minimum value. Just think about it. Okay, I hope you will be clear. When you want to stop the motion downward, the weight which you attach here will be minimum value. But you want not only to stop it, but you want to pull it up, right? It's about to, it's impending motion. It's not actually moving, but it's about to move. In that case, that value of W will be maximum. And think about it, when you are stopping this body from moving down, then what is the motion? I mean, impending motion. About impending motion of the entire system is going to be anti-clockwise, right? It's trying to move down, but it's not, it just stopped. It's not allowed to move down, so it's an impending motion. So if you find out W1 in this situation, that will be minimum value. I hope you are clear. Now let's consider, we are finding out that minimum value first, right? When you are finding out this minimum value, our usual way, you just find out the free body diagrams for 2 and 1, resolve them, and resolving, as I said in the last video, it's always convenient when you have an inclined surface, your x also should be in this direction along the surface, and perpendicular to this will be y, x and y. Similarly here for this case also, x will be along this and y will be perpendicular to it. Okay, right. So see what are the forces. This body is pulling up, right? Always this rope is under tension always. So it's pulling this body. So this is going to be T, tension. There is going to be normal reaction. This is normal reaction. I'll call this R1 because this is body 1, R1. And this angle is going to be 45. I explained it last time that if you have two planes angle between them is 45. Then, and if you draw normals to these planes, this W is normal to horizontal, this R1 is normal to this inclined surface, so angle between them will also be 45. Okay, fine. So you have how many forces? Okay, you have to consider one more force. What is that? That force is force of friction. The body is trying to move in this direction, see, right? So the frictional force will be in opposite direction. So frictional force here will be in this direction, and you are, let me tell you what is the coefficient of friction. Coefficient of friction here is also 0.25. I should have told this. This is mu is 0.25, right? So frictional force here is 0.25 into R1, correct? So similarly you can, so our weight now, which is unknown, and I can write this weight here as W1, which is unknown. Then this is tension, again the rope is pulling in this direction, so we are considering the effect of rope on this body, free body diagram. This is okay. Then we have normal reaction. This is R2. This angle again is 30, as you know. And what about the friction? See, this body is this body is in this moving in this direction, I mean anti-clockwise, about to move. And always when I say moving, in fact I meant about to move, is static equilibrium. So frictional force will be towards right. So this is going to be 0.25 into R2. 0.25 into R2. Fine. So if you know what you have to do, you have to put sigma fx is equal to 0, sigma fy is equal to for this, sigma fy equal to 0. Similarly, sigma fx and sigma fy is equal to 0. Again, remember our x axis is along this plane, and this is x, this is y, perpendicular. So it's easy to resolve the forces, and when you have these four equations, you find out this value of W1, right? Are we finding out W1? Yes, value of this is 1, W1. This value of W1 is going to be minimum value. I just explained, because we are stopping this. This W1 is only required to stop the movement of this body to slide downwards, right? We want to stop that. Okay, so that value, let me give you that value, is 1.85. Is 1.85 kilonewtons. Okay, 1.85 kilonewtons. Right. Now let's consider. We want to find out maximum value also. Right. So what will change? You know, what will change is, now what we want is, we don't want this body to just let me clear this. Okay, so what is going to change? What is changing is, we don't want this body to stop. We want to, it should be in the condition where it is about to move upward. Okay, that means you should add more weight so that it's about to move upward. So that means the movement now is clockwise. Okay, movement is clockwise. Then what is going to change? What is going to change is the direction of friction. This body is about to move towards right, so the frictional force is going to be in this direction, right? And again, the other weights are as good, same. This will be W, this normal reaction, etc. That's going to remain same. And frictional force here, so this is moving in this direction. This is going to be in clockwise direction. This is about, impending motion is towards in clockwise direction. So frictional force will be upward, right? Frictional force will be upward. It will be opposite to that of in first case. So just change the directions of frictions, that's it. And then you find out the weight, this weight which is acting downward, right? This weight, W1, that will be maximum weight. And this is maximum weight, and this is going to be 7.5 7.8 kilonewton. 7.8 kilonewton. That is going to be maximum weight. Remember, in both the cases, the system is under static equilibrium. In first case, the body is stopped from moving down. In second case, the body is about to move up, right? So you require more weight to be attached here. Thank you.